Hi everyone, today we are going to solve one more first order differential equation given in James Robinson's book x cubed plus y over x plus y squared plus ln of x times dy over dx is equal to 0. In its present form, it is not easy to be able to understand if it is exact or not. So let's write it in differential form. That is, by multiplying each side by dx, then the equation can be written as x cubed plus y over x times dx plus y squared plus ln of x times dy is 0. So let me name the coefficient of dx as m of x y and the coefficient of dy as n of x y. In the exactness condition, this equation m and n has to satisfy the derivative of m over derivative of m with respect to y has to be equal to the derivative of n with respect to x. This is the exactness condition. And now let's see if this equation is exact or not. So let me calculate derivative of m with respect to y. That is, the derivative of m is 1 over x, and derivative of n with respect to y again, since I derive this expression with respect to x, y squared, derivative of y squared is 0, and derivative of ln of x is equal to x. So the exactness condition is satisfied. So this equation is an exact differential equation. So it must have a solution f of xy is c. Of course, c is constant. C constant. Satisfying that partial derivative of f with respect to x equals m of xy and partial derivative of f with respect to y equals n of xy. So I can choose any of these equalities as starting point. In the study, in this video, I have chosen the first one, that is partial derivative of f with respect to x is x cubed plus y over x. Then when I multiply both sides by del x, that is del f equals x cubed plus y over x times del x, and integrating both sides, the left hand side is going to be f of xy is equal to, now I integrate the right hand side with respect to x, so it is going to be x to the power 4 over 4 plus y times ln of x plus, I put a generic function here, g of y, but in this form we don't know what gy is. But how can we determine g of y? Of course, I will now use partial derivative of f with respect to y is n of xy. So let me calculate it. Partial derivative of f with respect to y equals the derivative of x to the power 4 over 4 is 0, and derivative of y times ln of x with respect to y is equal to ln of x plus derivative of g of y is dg over dy is equal to n of xy, and of course I know that n of xy equals y squared plus ln of x. So by cancelling ln of x's, I can write dg over dy equals y squared. Then integrating both sides, I determine g of y equals y cubed over 3 plus c1. c1 is constant of integration. So now I can write the solution f of xy equals x to the power 4 over 4 plus y times ln of x plus y cubed over 3 plus c1 equals c. And this equation can be written as f of xy, of course, or let me delete it, x to the power 4 over 4 plus y times ln of x plus y cubed over 3 equals c2. Here c2 equals c minus c1. That is the solution. In this example, we solve an initial value problem for a first order differential equation given as 2 times x times y minus secant square x times dx plus x squared plus 2y times dy is 0 with the initial data y of 0 is 4. Okay, now since it is in the derivative form, let me check. First, let me name the coefficient of dx as m of xy and the coefficient of dy n of xy, and let me check the exactness condition, that is derivative of m with respect to y is, let me check this, derivative of n with respect to x. That is, now let me calculate the left hand side. Derivative of m with respect to y is 2x, and the right hand side derivative of n with respect to x, that's again 2 times x. So this differential equation is an exact differential equation, so it must have a solution in the form f of xy is c, satisfying that the partial derivative of f over x is equal to m of xy, and partial derivative of f with respect to y is n of xy. So now I will choose one of these equations, one of these equalities as starting point. In this video I have chosen this one, partial derivative of f over x is m of xy as starting point. So let me write it, partial derivative of f with respect to x is equal to 2 times x times y minus secant square x. By multiplying each side of this equation, I can write partial or del f equals 2xy minus secant square x del x, and integrating both sides, I can write f of xy equals x square y minus the integral of secant square is tangent of x, so let me write tangent of x plus a generic function of y, g of y. And now I will use in this step I don't know what g of y, but I will use the second starting point to determine it. So I know that partial derivative of f with respect to y is n of xy. So let me use this knowledge as, let me calculate partial derivative of f with respect to y, that is partial derivative of f with respect to y equals x square plus dg over dy, that is equal to n of xy. I know that n of xy equals x square plus 2 times y. So by cancelling x squares, I find a simple differential equation dg over dy equals 2y. And by integrating again both sides, I determine g of y as y square plus c1. So now I can write f of xy equals x square y minus tangent of x plus y square plus c1 equals c, and this form can be rewritten as x square y minus tangent of x plus y square equals c2, where c2 is equal to c minus c1. So now I have to determine c2 by using initial data. Since I know that y of 0 equals 4, that means when x is 0, results y is 4. So by using these values of x and y, I can determine c2. That is, when I substitute 0 here, 0 square times 4 minus tangent of 0 plus 4 square equals c2. Then this one is 0 minus 0 plus 16 equals c2. So c2 is 16. So the solution of initial value problem is x square y minus tangent of x plus y square equals 16. This is the solution.